Next one is Mie scattering. Mie scattering is just in opposite to this, where it says the amount of scattering is independent of wavelength. What happens, or where you can see this, is the appearance of the clouds. What's the color of the cloud? Cloud is white. Okay, so in those atoms and molecules, it refracts. After refraction, the light turns to white, wherein it is not going to depend on the wavelength. That is what is Mie scattering.
This video will focus on a simple demonstration that can be done in the classroom to illustrate how light is scattered by particles that are either similar in size or larger than the wavelengths of visible light. The demonstration is done on an overhead projector and requires a graduated cylinder, or preferably two, a mask for the overhead screen that matches the cross-section of the cylinders, a source of small particles such as powdered milk or pine sol, and a source of larger particles such as chalk that has been ground with a mortar and pestle. We will be placing our cylinders on the overhead, a source of white light. We can then observe the appearance of the water through scattered light, and of the spot made on the screen through transmitted light. Let's start with a cylinder filled with pure tap water. We can see that the water is best described as clear. There are very few particles in the water that can scatter light. The spot on the screen is white and hasn't changed much due to the water. We will now add a little pine sol to the water, a source of small particles comparable in size to the wavelength of light. It doesn't take much, and I will add it slowly to avoid making bubbles, and stir it. We will shortly place the water pine sol cylinder on the overhead mask. Let's see if you can make a prediction regarding the appearance of the water and pine sol when placed on the overhead. Classroom students should follow normal procedures or instructor guidelines. Viewers not in a classroom should record your vote and explain your reasoning on a piece of paper. Please pause this video and answer the question. Note that the water now has a bluish glow. This effect is called Rayleigh scattering. Small particles from the pine sol are preferentially scattering the short wavelength blue light, much better than the long wavelength red light. Note how the spot on the screen now has a reddish tinge due to this preferential scattering. A larger percentage of red light has passed through unscattered. In astronomy, we call this reddening. Rayleigh scattering is also responsible for the sky being blue. The oxygen and nitrogen molecules preferentially scatter the blue light back to our eye, while the red light preferentially streams through. Right around the sun, the sky appears red since more blue light has been removed. The principle of Rayleigh scattering shows up in landing and taxiway lights at the airport. You want these lights to be visible to pilots that have already landed, but don't want them to be seen high up by descending planes where they might be confusing. This phenomenon shows up in astronomical images, like in this open cluster known as the Pleiades, where preferential scattering of dust particles creates the blue glow. We'll now add some chalk dust to a second cylinder of water. The particles of chalk are large compared to the wavelength of visible light. Please make a prediction regarding the appearance of the water and chalk dust when placed on the overhead. Classroom students should follow normal procedures or instructor guidelines. Viewers not in a classroom should record your vote and explain your reasoning on a piece of paper. Please pause this video and answer the question. Note that the water now appears murky. A lot more light is being stopped. But there is no color dependence. It is white, as all wavelengths of light are equally likely to be scattered. This is called Mie scattering and occurs when particles are large compared to the wavelengths of light. Note that our spot on the screen is barely visible, but it doesn't appear to be any certain color. When we zoom in on the cylinder, we can see that the bottom of the cylinder is much brighter than the top. Extinction is occurring along the way as light travels through the cylinder. This is the principle that makes clouds white. The scattering agents here are water droplets. Since they are large compared to the wavelength